UGC Net Unit 2 Computer System Architecture December 2019 Questions with Explanation Part 2. First question. The following program is stored in a memory unit of basic computer. Give the content of accumulator register in hexadecimal after the execution of the program. The first instruction is CLA and ADD 016, BUN 014, HLD and 017, BUN 013, C1A5, 93C6. Here the explanation. CLA means clear accumulator. When clear accumulator, the accumulator value is set to 0. The next instruction is add 016. That means add the value at 016 to the accumulator. In 016, C1A5 is a value given to add to accumulator. Now the accumulator value is C1A5. Next, BUN 014. That means branch unconditionally 014. When we forward to 014, there is a operation AND AND 017. That means to perform AND operation, the value located at 017 and accumulator. In accumulator, the value is C1A5 and 017 value is 93C6 to perform AND operation between. The C1 binary value is 1100 0001 1010 0101 and 93C6 binary value is 1001 0011 1100 0110. To perform AND operation, we get 1000 0001 1000 0100. Thus, it is a equivalent value of 8184. The next instruction is halt. That means halt the program. When we perform all this operation, we get output on accumulator is 8184. Next question. A micro instruction format has microoperation field, which is divided into two subfields, F1 and F2, each having 15 distinct microoperation. Condition field has 4 status bits. Branch field BR having 4 operation used to conjunction with addressing field AD. The address space is of 128 memory words. The size of micro instruction is dash. The micro instruction format is F1, F2, CD, BR and AD. The F1 with 15 distinct microoperation, F2 with 15 distinct microoperation. Condition field CD has 4 status bits. Branch field has 4 options and addressing field has 128 memory words. Here we represent 15 distinct microoperation into 4 bit. Like F2 with 15 distinct microoperation, we represented using 4 bits. To represent 4 status bit, we use 2 bits. Like in branch field, we use 2 bits. To represent 128 memory words, we use 7 bits. So the total is 4 plus 4 plus 2 plus 2 plus 7 equal 19 bits. In this micro instruction, we use 19 bit. So the answer is 19. Next question. The reduced instruction set computer RISC characteristics are A. Single cycle instruction execution, variable length instruction format, instruction that manipulate operands in memory, efficient instruction pipeline. These are the characteristics of the RISC. Simple instruction, hence simple instruction is decoding. Instruction comes under size of one word. Instruction take a single clock cycle to get executed. More general purpose registers, simple addressing modes, less data type, and pipeline can be achieved. Here the option A and D are the correct. Single cycle instruction execution and efficient instruction pipeline. Next question. An instruction is stored at location 500 with its address field at location 501. The address field has value 400. A process register R1 contains the number of 200. Match the addressing mode list 1 and effective address in list 2. In list 1 we have direct, register indirect, index with R1 as a index register relative. In list 2, 200, 902, 400 and 600. We draw the diagram like this. In this question, the address field has value 400. It means the direct address gives 400. So option A match with 3. And register indirect address. That means a processor register R1 contains the number 200. That means register indirect address is 200. And index value is register indirect address plus direct address. That means 200 plus 400 equals 600. And the balance is relative address is next instruction memory location plus distinct address value. That means 502 plus 400. That means 902. So the first A is related to 400, A3, and B register address indirect is 200, B1, and C index with R1 as a index register is 600, C4, and D relative is related to 902. So A3, B1, C4, D2 is a correct. Next question. Match the list 1 and list 2. List 1 isolated IO, memory mapped IO, IO interface, asynchronous data transfer. And list 2 same set of control signal for IO and memory communication, separate instruction for IO and memory communication, requires control signal to be transmitted between the communication unit, resolve the difference in central computer and peripheral. Explanation. Isolated IO use separate instruction class to access the primary memory and device memory. So the option 2 is related with the separate instruction for IO and memory communication. And memory mapped IO uses the same address bus to connect both primary memory and memory of the hardware devices. So the memory mapped IO related with same set of control signal for IO and memory communication. Input-output interface is used as a method which help in transferring of information between the internal storage devices, that is memory and external peripheral devices. So it's related with resolve the difference in central computer and peripherals. And last, asynchronous data transfer between two independent units require the control signal to be transmitted between the communication unit so that the time can be indicated at they send data. So it requires control signal to be transmitted between the communication unit. So option 3 is a correct answer. A3, B1, C4 and D3. Next question. Match the list 1 with list 2. List 1 microoperation, microprogram control unit, interrupt and microinstruction. Explanation. In computer central processing unit, microoperation, also known as microops, are the functional or atomic operation of the processor. They are low-level instructions used in some design to implement complex machine instruction. They generally perform operation on data stored in one or more registers. So, the elementary operation performed on data stored in register is related with this. A control unit whose binary control value are saved as words in memory, it's called microprogram control unit. So, it related with control memory. An interrupt is a signal emitted by the hardware or software when a process or a event need to immediate attention. So, it's improve the CPU utilization. A computer instruction that activates the circuit necessary to perform a single machine operation, usually as part of the execution of a machine language instruction. So it related with specify microoperation. So here the option microoperation is related to elementary operation performed on data storage in register A4, and microprogram control unit B is related to control memory B3, and interrupt is a signal, it's related to improve the CPU utilization C2, and D micro instruction is referred to specify the micro operation. So D1.